People, when they look up in space, they imagine this black void where there's nothing really between Earth and other planets or other stars. And that's far from the truth.
It is the final frontier. We're still really excited about it. You put a kid in front of a rocket and how it's impossible not to be excited by it.
I'm getting it!
So we tend to think of space as something that's very, very far away. It's very empty. There's not anything in there. It's a big vacuum.
Space has terrain. Its terrain is not physical terrain like we see here on Earth. It's terrain of gravitation, of radiation, of trajectories, and of orbits.
It's a very dynamic environment, and society depends upon it. It extends everything we do on the ground up into the skies.
There is this linkage between the void of space and what's happening here on Earth, and it goes both ways. There's this really interesting terrain in space factor that people need to start visualizing and understanding, and it adds then a new dimension to how we think about space warfare.
We are dependent on space for a number of elements, things that we might not consider to be connected to space in any way, things like agriculture, road building, mining, all of these depend increasingly on the accuracy of the GPS signal.
Networked systems of sensors allow us to navigate, they allow us to have precision timing.
Things like the electricity grid, for instance, depend on this. So if that goes down, many functions on which we rely go down, and the economy or a number of other aspects and start to be affected immediately, and society could just stop.
Without space, we would have a very different world. A lot of the technology and the connectedness of society is driven by our space technology.
If we lose space, we lose the war, and we lose it fast.
Ancient humanity worshipped the sky above. They learned that celestial objects played a part within the universe and daily life. Recordings of zodiac constellations were made by both the Chinese and Babylonians some several hundred years before the Common Era. Explorers began to use the stars to navigate. And then, in the early 1600s, Galileo Galilei tilted his telescope toward the stars and saw deeper into space than any human ever had before him.
There's only a few things that you can do in space or to space. You can look at things, so you can have optical telescopes, and that can either be from space looking at the ground or from ground looking at the space. You can listen. You can broadcast into space, connect the satellite, and then broadcast that down to the ground, or likewise from space you can transmit.
From the ancient world to the modern era, humanity's fascination with space began when we turned our gaze upward. It wouldn't be long, however, before humanity began wondering how to conquer it. But to conquer it meant we had to venture into it. This possibility began only several decades ago, when technology allowed us to skirt the atmosphere.
The military have always been interested in space. From World War II with the V2 rocket that really marked our first efforts to leave the Earth's surface and enter orbit.
The Kármán line is an area between the Earth's atmosphere and outer space. Here, where the atmosphere is so thin, soared the German-developed long-range guided ballistic missile, the V2. Designed to target Allied cities such as London in World War II, powered by a liquid-propelled rocket engine, the V2 rose beyond the Earth's atmospheric threshold, making it the first human-made object to travel into space.
The space race began at the end of the Second World War, and in particular between that great power rivalry between the United States and Soviet Russia.
Both the Soviet Union and the United States recognized the obvious military advantage in exploiting space. The first steps of the space race were to recruit or coerce the best minds of the time to improve upon existing technology. Recruiting and coercion began post-World War II. At gunpoint, the Soviets seized about 2,200 German specialists, 6,000 family members in total, from Soviet occupation zones to work on Operation Osovyacum. The U.S., in turn, secretly relocated some 1,600 German scientists for their equivalent program, Operation Paperclip.
Among the scientists that America rounded up was Werner von Braun, who later became the sort of so-called founder of the US space race.
Dr. Werner von Braun, an aerospace engineer and space architect, was at the vanguard of Germany's rocket program. With the Cold War looming, the desire to be first in space, to understand and harness its potential, to assert military might, to display technological prowess, drove the Soviet Union and the United States to push each other fast into uncharted territory, into the outer atmosphere of our Earth.
There was this level of competition between these sort of two enemies in the start of the Cold War around rocketry.
Scientists working on Operation Osovyacum and Operation Paperclip quickly developed short and medium-range rockets, ICBMs, intercontinental ballistic missiles.
And so with ICBMs, they're designed to travel a long distance over Earth's surface, but also, because of that, can go a long distance up. So a really good demonstration of ICBM's power is its ability to reach space. If you can go into space, you can also hit Moscow or Washington.
Soon they began to learn more about the Earth's properties and magnetic fields. Even after the lengthy Cold War silence, the Soviets, Americans, and some 65 other countries came together to exchange ideas at the 1957-58 International Geophysical Year.
Those charged with the United States satellite program determined that small satellite spheres would be launched as test vehicles during 1957, and that the first fully instrumented satellite would be launched in March of 1958.
The outcome? America and the Soviet Union agreed to launch low-orbiting satellites. But then,
the Russians beat the Americans to the punch, and on 4th of October launched the first satellite called Sputnik. It was launched on a Soviet R-7 rocket and reached Earth orbit.
And that came as quite a shock to the US, because first of all, the US didn't realize the Russians had that capability, and also it beat the US into space by about 3 or 4 months.
And in fact, it was only after a couple of orbits that anyone noticed it was there.
It was a sudden realization, I guess, that there was an opponent above them, looking down on them.
The average American could walk outside their house in the middle of the night and literally see this satellite, little twinkling star in the Earth's sky.
It was still the first man-made satellite in orbit, and so that created quite a ripple in US security communities.
This is where we see the beginning of the space race, this idea that America, supposedly the most powerful nation on Earth, is behind the Soviet Union. And they sort of scrambled to catch up.
That was the very first satellite that was designed to perform a science mission, but there was obviously a significant amount of strategic and military interest in there as well.
There actually has been quite a large military presence in space right from the very beginning. Sputnik was actually a military satellite. A lot of the early astronauts and cosmonauts were military members.
The military are very interested in space for its ability to provide a global coverage.
Space and security concerns have been intertwined right from the start.
You can fly your satellites pretty much anywhere over the world, and you can use them to look at things, you can use them to listen to things.
Sputnik was very much a strategic shock for the United States because it demonstrated the power of Soviet ICBMs and their ability to reach the United States.
To communicate with troops and facilitate basically every aspect of armed conflict.
Right from the start, space was seen as the ultimate high ground in a military sense.
A lot of the early satellites had weapons on them, so there was actually a Russian satellite that had a cannon on it.
Soviet 23 or 30 millimeter cannon being attached to one of their early military space stations. That was the only example of a weapon being sent into space. They tested that and then deorbited the space station later on.
Salyut 3, a Soviet space station launched under the highly secretive Almaz program. Not only did it contain a number of cameras designed to observe Earth, but it was equipped with a self-defense gun, the Richter R-23.
They weren't very useful because the only way to aim them was to actually turn the entire satellite.
On January 24, 1975, just hours before the Soviet space station was decommissioned, the R-23 cannon was test-fired in space.
There are already weapons in space. There are some very suspect objects in space that a number of us suspect aren't communication satellites.
Weaponizing space is different to weapons being used in space. Surprisingly, there are perhaps fewer examples of weapons being used in space than people might believe.
The example of where countries have launched weapons into space, the Starfish Prime tests, nuclear testing in the early 1960s.
In the summer of 1962, the United States launched Starfish Prime, one in a series of high-altitude nuclear tests in response to Russia ending a 3-year testing moratorium. A 1.4 megaton thermonuclear warhead was carried into space on a rocket named after the Norse god Thor. 400 kilometers above Earth, it was detonated. Starfish Prime became the largest nuclear test to occur in space. However, testing nuclear weapons in space creates an electromagnetic pulse. It can disable satellites and wreak havoc on terrestrial electrical systems and microwave radio transmissions.
An electromagnetic pulse at the right altitude can have an impact over a huge area of the Earth's surface and affect a lot of the electronics that are not properly shielded or protected.
When human beings started exploding nuclear weapons in space, not only did they find that trapped high-energy electrons formed radiation belts around the Earth, they soon discovered that space debris was now a problem.
A lot of the debris sort of linger from that particular bomb, and those debris travelling very fast are very, very damaging to sort of satellites around there.
There are various orbits around the Earth, from medium to low, polar to geostationary. Satellites use different orbits for particular reasons, from predicting the weather to military reconnaissance. Orbits cluttered with space debris make for perilous space operations.
It's important to understand the particular characteristics of space that mark it out from other domains. In space, if you send anything fast enough, it's a weapon. So a little bolt going at 20,000 kilometers an hour is essentially a missile.
In the late 1970s, NASA scientist David J. Kessler concluded that space debris from tiny objects to large abandoned launch craft or non-functional spacecraft were extremely hazardous to ongoing space operations. As space debris collides, an exponentially increasing amount of debris is created. This is known as the Kessler syndrome.
We can see the debris from our continued use of space. Bits of old rocket boosters, screws, even a wrench has been lost in space. There's a lot of different things that space debris consists of.
When those hits your satellite, it's going to go straight through it.
The energy contained in a 1 centimeter particle hitting a satellite at that velocity roughly corresponds to an exploding grenade. So the consequences of such a hit mean a satellite failure, for larger objects, even a satellite destruction. and fragment generation then has environmental consequences.
And despite knowing the risks, space debris has continued to accumulate, not least because of anti-satellite testing.
For a very long time, the major player in the space is actually United States and Russia. But in more recent times, and especially in the post-Cold War period, and there are some other emerging powers in the space, and in particularly China and India.
We haven't had space warfare so far, but when we think about how space warfare might emerge in the future, what you focus on very much is anti-satellite weapons. The sorts of capabilities that China and Russia and India and others have tested to be able to either physically destroy a target satellite or to disable it.
Counter-space capability can be divided into the so-called soft kill or hard kill.
A hard kill, or kinetic kill, is volatile. It's about obliterating space assets. This usually involves a direct ascent anti-satellite weapon taking out a target.
In the 1980s, the Russians and the Americans both tested anti-satellite missiles. They had a moratorium on that for a while. They realised it was in neither of their interests to develop anti-satellite missiles. But then in 2007, the Chinese tested an anti-satellite missile.
The 2007 Chinese anti-sat test drew significant response from the international community. It was quite high, so the amount of debris that was created was vast, and it causes us problems to this day.
The destruction of the satellite by this test created more than 3,000 trackable pieces of debris, which caused considerable threat to the other satellites in the space as well. The Chinese test is actually a wake-up call for the United States, and which make the United States aware that China had made significant progress in the counter-space capability.
From a strategic perspective, you can see why they would want to do that. The United States derives great benefits from its space capabilities. It's one of the asymmetric advantages that the US would have over China. So how does China balance up the checkbook, so to speak? They can do that by developing counter-space capabilities to deny the US its advantages that it gets from space capability.
We've seen the Chinese and the Russians and now the Indians test direct ascent ASATs. The Americans did one in 2008 called Operation Burnt Frost, where they took out a malfunctioning satellite in very low Earth orbit.
The Indian anti-satellite test was likewise not the most responsible activity to do, partly because they don't have much in the way of ground-based sensors. So they created all of this debris, and then it was a problem for someone else, mainly the US, to keep track of all these pieces of debris and ask everyone to stay out of the way of them.
The good thing about space is it's pretty empty, so the distances between a lot of this debris is quite large, and often you can move satellites prior to a piece of debris coming close to them, because of course we can track a lot of this debris using radar down to say a centimetre or lower. We can track each individual piece.
European Space Agency figures released in 2020 estimate close to 1 million objects between 1 and 10 centimeters in length, 34,000 objects greater than 10 centimeters, and 128 million objects 1 centimeter or less. In future warfare, ground-based military operations allow for a variety of defensive space maneuvers to occur, which can lessen the risk of further space debris accumulating.
As a result of the problems that could derive from a kinetic strike in space, it's more likely that we'll see soft kill capabilities.
A soft kill capability is the interference of sensor-based systems or sensor-based weapon systems
Soft kill, which are the capability which can temporarily disable or deny the use of space capability and by one's opponent.
For example, a cyber attack where you just switch it off. You've not hit it and caused it to fragment into thousands of pieces. You've just stopped it from working.
Things like spoofing, jamming, or maybe dazzling with a laser, or blinding a satellite. Illuminating the satellite, but with enough power that it would blind the satellite. So optical sensors, for instance, could be overloaded, and that's why we say dazzled.
An example would be ground-based lasers shining up at satellites. You can use it to dazzle a satellite so that it can't operate.
Other concepts are things that we call co-orbital anti-satellite weapons. And those would be a satellite that would orbit along with or alongside, say, your target satellite. Those might be in orbit for many years. You might not know it's a weaponized satellite. They could be sort of a sleeper satellite in some respects. And all they need to do is bump into it.
It's very hard to know if you've been deliberately attacked or whether another satellite has just gone out of control and bumped into you.
Then we get into things such as active debris removals. Harpoons, nets, electromagnetic tethers to try and grab dangerous pieces of space junk that threaten our orbital environment. Those could also be used as a weapon to grab an active satellite.
Sounds a bit James Bond, but they could actually collect that satellite and take it down to Earth. You know, there's a number of things that you could do with a co-orbital satellite depending on the design, etc.
We are seeing space as now contested in every sense. We are seeing adversaries like China and Russia starting to develop very sophisticated counter-space capabilities that are threatening our traditional advantage in terms of a knowledge edge.
A soft kill may have its advantages in reducing space carnage, but it also opens the doors to a new series of potential vulnerabilities.
The more states are dependent on space, the less likely it is that they will be starting to throw around kinetic capabilities in space and be looking for some of these jamming or dazzling or those kind of capabilities. And then you can perhaps deliver to the enemies a great deal of disinformation via their own satellites if you're able to hack into them.
Basically, it's designed to disable rather than physically destroy. And that has real advantages because it allows a degree of deniability.
There are a lot of challenges around attribution, particularly around countries, particularly America now, who's saying that any attack on a satellite would be an attack of war on them, and that has a compound effect.
We need to have a factual basis to determine that we have been interfered with in an intentional way, and an evidentiary basis.
How can they be sure who their adversary is? Do they just randomly pick a country?
What warfare looks like in space is really hard to predict. We can see the kinetic effects of some of these kind of weapons, but there might be a number of other methods that we just aren't really aware of, or if it happens, we're not sure. Is it space weather, or is it perhaps, a malicious actor? We're not quite sure exactly who's doing what.
Our imagination held launches from Earth, devised ways to harness an orbit, land us on the moon, and now venture beyond. The race to dominate this newly contested environment means adversaries will engage in war in ways that have never been seen before.
We expect foreign governments to expand their use of space-based reconnaissance, communications, and navigation systems. And China and Russia will continue training and equipping their military space forces and fielding new anti-satellite weapons to hold U.S. and allied space services at risk. Space has become the new global frontier, with competition from numerous nations.
Space for a long time has just been taken for granted as a region, as an enabler for terrestrial military operations. We always assumed that air, naval, and ground forces would have access to space systems to function. That assumption now is directly open to challenge, and I think probably its time has passed.
Our adversaries have been working to bring new weapons of war into space itself, from anti-satellite weapons and airborne lasers to highly threatening on-orbit activities and evasive hypersonic missiles. Both China and Russia have been aggressively developing and deploying technologies that have transformed space into a warfighting domain.
In the space domain, the rules of engagement are being laid down, and one of the most important factors is speed. The emerging field of hypersonic weapons has challenged the idea of what weapons in space may look like, as well as what methods of defense may be required against them. Railguns launch projectiles up to 100 miles at a hypersonic speed of Mach 7. Using electromagnetic force, highly charged electrical particles generate magnetic fields. These magnetic fields propel sliding metal conductors, which launch the missiles toward their target. Destruction comes, not by explosive detonation, but by the projectile smashing into the target at unimaginable speed, at hyperspeed.
Hypersonic weapons are weapons that travel through the air at speeds in excess of Mach 5, so that's 5 times the speed of sound.
And most of the hypersonic weapons developments are looking at velocities that are ranging from about Mach 6 through to about Mach 10.
Russia's Avangard is one such weapon. In 2018, Russia alleged that in tests, this missile reached speeds of up to 27 times the speed of sound. This hypersonic missile has an intercontinental range, a maneuverability capability that makes it near impossible to intercept, and the ability to carry a 2-megaton nuclear weapon. It is a weapon of future warfare.
How do you detect hypersonic weapons that are moving maybe as fast as Mach 10 early enough to be able to defend against them?
If you're traveling at, say, Mach 8, the temperature a small distance away from the surface of your airplane or your missile can get to around the same temperature as the surface of the sun, so it can get to around 3,000, 4,000 Kelvin. The speed that things happen become very challenging.
If you imagine, for example, a naval task force at sea, by the time the hypersonic weapon is detected, you've got maybe 14 seconds to be able to defend against that threat, which is not enough time.
If future warfare happens at hypersonic speed, one measure of hope against a missile traveling at such incredible velocity is for a space-based series of sensors and defensive systems to recognize a threat and respond rapidly.
Having something like AI on board that's able to monitor the system and predict when something's going to happen before it happens and take mitigating issues would be very beneficial.
As we start to then get, say, major opponents trying to take down space capabilities, that could be catastrophic again for all these ground-based services that we depend on now increasingly. And that's a really debilitating scenario.
And you see the potential then for what people call a space Pearl Harbor, whereby an adversary can maneuver anti-satellite weapons close to their targets and then unleash a decisive strike prior to or at the outset of a military conflict to disable critical capabilities and leaving us, in effect, deaf, dumb, and blind.
As the contested environment of space becomes ever more congested, superpowers vie to position themselves by using technology that sets them apart, establishing dominance amongst an ever-cluttered field of private industry and military interests.
There is a concern now about the militarisation of space, but it's actually been happening for quite a long time. What has happened recently is we're actually talking more about it, whereas previously it was quite hidden in secrecy.
China actually realized that the United States has a far stronger and superior military space program and capability. So it developed its counter-space capability largely to give itself a kind of deterrence.
We are moving into a period where space warfare is probably going to happen in the next big war.
space now is perceived as a very important part for China's national interest, and both for military and civilian purpose.
It's highly likely the Chinese and the Russians will move against our space capabilities from the outset. So we're scrambling to respond to that challenge.
Superpowers are invested heavily in space. In 2017, China's space and military budget was close to $9 billion. Russia's was about $3 billion. In 2020, the U.S. Department of Defense requested just over $14 billion for space programs. The money is spent not only on space exploration. Much of it is dedicated to developing military capabilities, which give superpowers an edge.
The key to success in future warfare is really gaining and maintaining an information edge over an adversary. And critical to that is, of course, space-based capabilities for command and control communications and computers, intelligence, surveillance, and reconnaissance, the so-called C4ISR factor. At the moment, the focus is on quantum cryptography and quantum communications. The Chinese have deployed a satellite called Micius, which is designed to test quantum communications by sending quantum entangled photons along long distances.
In late 2016, China launched the quantum-enabled satellite Micius.
They sent 2 quantum entangled photons at a distance of about 1,200 kilometers in 2016, which was the longest that anyone's ever done. And it forms the basis potentially of a ultra-secure satellite communications system and quantum internet in the sky that would give the Chinese military a far more sophisticated C4ISR capability than what we would have if we don't develop this.
Micius delivered encrypted, unhackable communication through the transference of minute subatomic particles of light. These light particles then travel by laser across space toward precise targets on Earth.
Certainly the military implications are that they would have a command and control communications system based on quantum communications and cryptography that we couldn't break, that we couldn't eavesdrop on, so therefore we couldn't understand what it is they're doing in terms of their command and control, and that's pretty significant.
China is a fast-growing, space power, and it currently, has a very ambitious space program. And even if China is a later comer in the space, but its capability growing very quickly.
You're going to see probably the Chinese push ahead with a second-generation quantum communications system with new satellites to test even more sophisticated application of this physics. And they might beat us to it in terms of quantum communications and quantum internet.
But over time, and China and the China space program has been driven by more concrete commercial, economic, and also military interest.
You really want to see what the future of warfare looks like. You look at Google and Facebook and Microsoft and SpaceX and so forth. And you look at these civilian technologies and how they can be applied to military purposes. And quantum computing is one area, artificial intelligence is another area where the Chinese have a huge lead.
Any nation's military that can harvest information and analyze vast amounts of data at speed has the upper hand. During the first Gulf War, the United States used information technology to dominate the battle space. Scrutiny from space gives an adversary a profound advantage.
So if we say information is power, we can see this perhaps shifting to what we call new space players or commercial entities. We're looking at the prospect of constant sort of 24/7 global surveillance in high definition at any point on the globe.
What China wants to achieve is the so-called information dominance. Space is an important domain of informationized warfare. And space dominance is a fundamental objective and for China's strategic and military planner.
And certainly Chinese and Russian military thinkers understand the great information advantage that American space power gives them, and they'd be very keen to limit that or attack that in any kind of conflict.
Collecting, controlling, manipulating information. Future warfare relies on a steady stream of quickly absorbed data.
Every state recognizes the importance of the space environment for providing space support to terrestrial forces. So satellites for communications, intelligence, surveillance, reconnaissance, precision, navigation and timing.
The push is on for the military sector and private companies to use space as a way of harvesting information, not only on enemies, but on private citizens.
In terms of how different countries are developing space, there's a much more vibrant commercial sector in the US than there is in China and Russia. And given those kinds of governments, those authoritarian governments, they're quite reluctant to relinquish control, to really allow the commercial sector to set it free, if you like, in that respect.
And if you want to speculate out to, say, the next 30 to 40 years, you could see human activity, both state and non-state actor, expanding out to the moon and beyond, and competition between major powers occurring in that vaster astrostrategic terrain.
Space is contested by superpowers, private companies, even individuals. Dominating it is a way to dominate Earth. But as in every skirmish across all domains, military engagement seeks to follow an established set of guidelines, ethics, rules.
As we've thought about ethics over thousands of years, we've recognized that the environment does matter. So we've got different rules, for example, for shipwrecked sailors than we do for soldiers who are separated from their units.
Does the same framework apply to conflicts terrestrially as they do into space?
The law of armed conflict doesn't identify space as a special domain in which special rules would apply. The same general rules of the law of armed conflict would also have to be applied to any military operations undertaken in space.
There are 5 space-specific treaties: the Outer Space Treaty, the Liability Convention, the Rescue and Return Agreement, the Registration Convention, and the Moon Agreement. The Outer Space Treaty in particular is sometimes regarded as the constitutional Magna Carta for outer space. It has very broad aspirational principles in the Outer Space Treaty.
We have never succeeded in freeing our planet from the implements of war. But if we cannot yet achieve this goal here on Earth, we can at least keep the virus from spreading. We can keep the ugly and wasteful weapons of mass destruction from contaminating space. And that is just exactly what this treaty does.
And one of the really tricky questions is how those specialized space treaties interact with the general rule of the law of armed conflict.
The way that legal boundaries work terrestrially work very differently to space, which creates a whole range of ethical issues.
Space is seen as common heritage of mankind that states should have equal access to.
We have over time become quite reliant on satellites and reliant on our use of space. The ethical problems posed by space is only going to grow.
But there certainly are going to have to be new distinctions as we think about ethics in space.
In space, battle lines are blurred, the dark side of the moon exploited. Within this void, military capabilities mesh with the interests of private stakeholders. Instruments of information, from spacecraft to satellites, are mobilized for war, business, pleasure.
private sector is now entering, and Elon Musk has got plans for passengers and all sorts of private enterprise activities in space.
I'd like to introduce the first paying customer of BFR, Yusaku Miyazawa. Please come forward. Yeah.
Thank you, Elon.
Opening up the commercial launch segment has really changed the whole face of what we do in space and what you can use it for. We're in a new space race with a lot more actors.
With Earth's natural resources being depleted, space represents an unmined opportunity.
There are three reasons that countries might expand their empires. God, if we want to spread our particular religion. Gold, is there money there? Can we make money? Spice trade, those sorts of things, finding new resources. And glory, does this reflect our national prestige? America and Russia fighting for that sense of national prestige, that sense of national power.
Very importantly, I'm hereby directing the Department of Defense and Pentagon to immediately begin the process necessary to establish a Space Force as the sixth branch of the armed forces.
All trying to find that sweet spot between how they can find their advantage, both in the commercial and the national and probably the military side of things.
In future warfare, a space asset is a nexus point where state, civil, and military interests combine, an intermeshing of space operations with the private sector.
Suppose Elon Musk succeeds in getting one of his ships to some neighboring planet where there are very worthwhile and valuable materials. Where we are right now is considering the exploitation of space for private gain by corporations. Should this just be left to the free market, or should states have some say in what happens up there? And if you say states should have some say, then the question is, which states? There might be some considerable disputes by other states at a single private individual.
Ignition, liftoff.
A commercial satellite, depending on how that satellite is being used, could constitute a target, a legitimate, valid target. But what happens if a neutral state is one of the parties that are engaged in or involved in that satellite?
Outer space treaty requires that there's a launching state. So even if you're a commercial actor, there's a state's name is on the ticket, basically.
So much of sort of space coexists between this military space and the civilian use. And so those two have pretty much comfortably, or with a little bit of tension, coexisted since the start of the space race.
The importance of space and in future warfare cannot be overestimated, because given the tremendous consequences of war in space for the humankind and also for the socio-economic activity.
So you've got the International Space Station, which is a sort of a shining example of the way that countries can interact peacefully in space, and indeed is used as a diplomatic tool to bring two former enemies, Russia and America, together.
There's an increasing understanding that space is absolutely critical for both military functions as well as a lot of civilian functions. We will see a rise in the importance of space. Alongside that, there's always a desire to protect economic interests in any domain, and space is one of those, and it has a massive impact on the balance of power, why we might go to war, and some of the outcomes of those wars and what we do terrestrially as a result.
The bad news is that we're going into that as a contested space environment where warfare in space is a real likelihood. The major powers are developing the sorts of capabilities for space warfare.
There have always been outlier countries, rogue actors, chagrined adversaries contesting to dominate. In space, in future warfare, the race continues.
The common misperception about space warfare. It's easy to conduct and also it's quite effective. But in reality, and actually, space warfare is like the nuclear warfare. And people tend to undermine the significant consequences of space warfare.
Future space warfare will come in ways that have only been hinted at, and it may change humanity in the blink of an eye.
If it happens, it will be fundamentally new and different compared to what's happened in the past. It will be just as important in terms of shaping future warfare as, for example, nuclear weapons were in 1945. And so we are facing the future where in war, not only will we be fighting in the air and on sea and on land, as well as in cyberspace and across the electromagnetic spectrum, but we'll also be fighting in space.
With hypersonic weapons, quantum communication systems, hard and soft kills, humanity pushes into the abyss, finding new ways to explore, to challenge, to dominate and determine our future.
It's beyond doubt that the importance of space in future warfare will grow, and with the technology development.
You'll see probably in the next 50 years, Trump's Space Force, if it happens, will evolve so that you will see an American military space capability around the moon, a Chinese military space capability around the moon, and the potential for competition and conflict to occur at that location.
And in fact, one of the things that we're dealing with when we look at the space environment, it's not actually separate national programs. It's an integrated supply chain with components that come from multiple countries all working together. That may be a comfort because we may think it's unlikely we'd fight someone that we're so economically intertwined with. History suggests we'll probably fight them anyway, but it'll be pretty messy when it happens.
We're entering a new golden age of space exploration where we're going to be achieving so much more than what we've achieved over the last 50 years in terms of going back to the moon, going on to Mars, having commercial space operators, having a great deal more human presence up in space, including beyond Earth orbit, compared to where we've been stuck for the last 50 years.
Human beings have long contested the domains of air, land, and sea. Now we are racing toward a new domain. How we use space will decide our earthly fate. A future determined not by any previous war, but by looking to the sky above, past the stars, and beyond.